Disadvantage of a reflecting type telescope over a refracting telescope. Limitations of reflecting type. Normally they don't ask that, they'll ask you limitations of refracting type telescope. Anyway, because they are normally open, the mirrors have to be constantly clean, it is all exposed to the outer atmosphere. That is one disadvantage, whereas in the case of refracting type telescope, everything is concealed. And unless the mirror and their optics and other optics are kept at the same temperature as the outside air, there will be air currents inside the telescope that will cause image to be fuzzy. So this is something you can write, at least one only they've asked, you can write the first one. If that is very hard, I would not have answered that. Okay, so let's go to next question. It's the 14th question. Draw a ray diagram should show formation of images of a compound microscope. When the final image is the least distant of distinct vision, obtain an expression for the magnifying power, which I have taught you in the class. 15th question. A beam of light converges at a point P. A beam of light is converging at a point P. A concave lens of focal length 24 cm, which is in negative, is kept in the path of the convergent beam 12 cm from P, which means you have to put this as a dotted one, so that you this is going to diverge it, correct? This is a diverging lens, obviously it will diverge and it will tend to come from a point behind. So this is what it is, this is where the final image V is, this will serve as an U. Both of them are on the right side, you know 1 by F is equal to 1 by V minus 1 by U. But F itself is negative, minus 24 is equal to 1 by V, you don't know, but you know that U is 1 by 12, which is to the right only. So 1 minus 1 by 12 minus 1 by 24 plus 1 by 12 is equal to 1 by V. So 24 is the LCM into 2, minus 1 plus 2 is equal to 1 by V. So 1 by 24, so V is equal to 24. So how is it possible for, according to me it's converging, shouldn't it be lesser than 12, why is it 24? Let me do it again. 1 by F is equal to 1 by V minus 1 by U. F itself is the focal length, which is minus 24. And you know that U is from the, at a point P initially is 12, so minus 1 by 12. V you don't know. It's to the right, so it's positive. When it comes to the left, it becomes negative, becomes positive. Minus 1 plus 2 is 1 by 24. Means V is 24. Okay, that is what we are getting. So whatever you get, you write that as the answer. So which means it's going to go, yeah, it is diverging, but still it's forming an image beyond. I'm surprised. Okay, so let me read the question again. A beam of light converges to point P. Now a concave lens of focal length 24 cm is placed in the path of the convergent beam 12 cm. Okay, at the point Q, does the beam converge? Now the convex lens of focal length 12 cm is placed at a distance of 12 cm from the concave lens in the path of the refracted ray from the concave lens. Oh God, okay. This itself is complicated for me. Can you imagine they have included something else? Let me think about it, okay? See, I've just checked on the internet. It's okay to get it like this. It's okay to, whatever you get, you just write, okay? So probably it is diverging, yeah, it is a diverging lens and all that, but still you're getting an image which is farther away from here. That's what it says according to this. Because of the focal length, it is changing, okay? So then you're getting an image which is farther away. That's where your image is, and so then it's diverging like this. So whatever you get, you just write it. So then you get V to be at 24. Now there's a second part of the sum where now a convex lens of focal length 12 cm is placed at a distance of 12 cm from the concave lens in the path of the refracted ray from the concave lens. So are we placing it here? Just at 12 cm on the path of the refracted ray. Yeah, which means it is exactly where the first image is. Now a convex lens of focal length 12 cm is placed at a distance of 12 cm from the concave lens in the path of the refracted ray from the concave lens. How much the point Q gets shifted after introduction of the convex lens? the separation between them is 12 centimeter. So the object is located, it seems like the object is located at the optic center. Okay, so let's approach the sum as a new sum. I don't know how to approach the sum, to be very honest. The distance between them is 12 centimeter. Normally the formula is 1 by f1 plus 1 by f2 minus d by f1 f2 for the combination, but that's a combined focal length. That's a combined focal length. Something I need to think about, guys. Keep this sum pending. We'll explore this in the class. Okay, we'll just discuss more about this in the class, because then the object. Okay, you know that for the second lens, let's do this is 24. So then find this full is 24, and so this is at 12. So this will be at 12 centimeters. So you know that this is going to serve as an object for the convex lens, whose object distance u is equal to 12. So now let's talk about the convex lens. So convex lens or focal length is given to be 12. So 1 by f is equal to 1 by v minus 1 by u. You know that the object distance to the right, which is 1 by 12. Focal length is also 1 by 12 is equal to 1 by v. So then therefore infinity, image will be formed at infinity. Introducing where that's what strikes me. Let's discuss about this in the class and let's see if what I've answered is right. This is what I would write. Okay, let's go to next question. The next question is the second part of the sum, wherein they have given calculate the focal length of the convex lens if the concave lens of focal length 15 centimeter is combined with a convex lens. Calculate the focal length for convex lens. The concave lens of focal length 15 centimeter is combined with a convex lens. So calculate the focal length of the convex lens is the question. The combination of focal length is 30 centimeter. Combined focal length is 30 centimeter and behaves like a divergent lens. It behaves like a divergent means concave, behaves like a concave lens, which means it has been combinations focal length has to be minus 30. 1 by f is equal to 1 by f1 plus 1 by f2. So 1 by the concave lens is minus 15 plus 1 by f2 is a convex lens focal length. The combination is minus 1 by 30. So minus 1 by 30 plus 1 by 15 is equal to 1 by f2. 30 is the LCM, minus 1 plus 2 is 1 by f2. So 1 by 30 is equal to 1 by f2. So f2 is equal to 30. So the convex lens or focal length is plus 30 centimeter, whatever that is. Okay, so let's go to next question. Section D. A thin lens is transparent optical medium bounded by two surfaces. Okay, at least one of which should be spherical. At least one of its spherical. One can be spherical, one can be plane. One can be plane, one can be spherical, both can be spherical. The focal length of the convex lens can be determined by using lens maker's formula or thin lens formula. The power of the lens is a measure of convergence or divergence. Which a lens introduces, the light falls on it. What is the question? Okay, that's I think a case study. The power of the convex lens is a measure of convergence or divergence. Power is normally reciprocal of focal length. What are they saying? Convergence, which lens introduces, the light falls on it. Yeah, convergence, it's nothing but the focal length also, no? So then power of convex lens is 5 diopter. Convex lens is 5 diopter. The radius of curvature of the first surface is this one, is 20 centimeter, and that of the refractive index of the medium is 1.5, and the refractive index of the surrounding is 1.33, which shows that the light is going to enter from water into glass. Okay, it's going to enter from water into glass. Okay, the radius of curvature of second surface. you know that 1 by f is equal to mu of glass with respect to liquid minus 1 into 1 by r1 minus 1 by r2. And so 1 by f is the focal length. The focal length is given as 20 centimeter. Mu of glass with respect to liquid is mu glass by mu liquid, which is 1.5 by 1.33 minus 1 into 1 by r. The focal length has been given, the focal length of the combination, 5 diopter, so reciprocal that you will get it's 100 by 5. So then therefore, so focal this itself is power, which itself is 5. Don't write 1 by f, just write it as 5. 1 by r1 is given to be 20, 1 by r2 is unknown. So just do the calculation and get your answer, that's all. That will give you the answer for the second surface's radius. And that has got to, R2 when you found out, has to be written in negative finally, because you know R2 is on this side. After finding it, you can't use the sign convention before itself, okay. So let's go to next question. Next question is 7th question. The focal length of the lens is maximum for incident ray. The focal length is greater for the longer wavelength. The red light has got the longest wavelength, hence the focal length will be maximum for it. So let's go to 17th is over. 18th question. An object is placed at distance u in refractive index n is equal to 1 for a convex spherical refracting surface. A convex spherical refracting surface having a radius of curvature r is equal to 30 centimeter. Object is placed at a distance of u in air, so object in the rarer medium. Okay, and this refractive index is 1.5 and image, okay, and it forms a virtual image at a distance of 30 centimeter. V is at a distance 30 centimeter, forms a virtual image. So you know the formula for when image is in the rarer, 1 by mu2 by object is in the rarer medium, mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. Mu2 is 1 by 5, V you don't know, minus mu1 is 1 if it's in air, the object is placed distance air now, by U you don't know, is equal to mu2 minus mu1 is 0.5 by R is 30, and they have given V to be 30, they have said it to be virtual image. Okay, let me read the question again. An object is placed at distance of u in air, convex spherical refracting surface of radius of curvature 30, refracting index of the medium is 1.5, it forms a virtual image at a distance of 30 centimeter. So it forms a virtual image. Okay, let's see, it has to be on the same side as the object, that's what a virtual image means. So then therefore V also has to be negative in that case. When you are substituting V as 30, you can't write 30, you have to write minus 30, because virtual image means you're going to, object is also in the rarer medium, image is also in the rarer medium. Do you agree with me? Minus 1 by u is equal to 0.5 by 30. When you do the calculation, you will get what is u, and that should be the right answer. Let me see, this will be 15 by 300 with a negative sign, 15 2s are 30, minus 1 by u is equal to, this will be 5 by 300, and so then 6 by 30, 60, minus 1 by 20, minus 1 by u is equal to 1 by 60. So 1 by u is equal to minus 1 by 20 minus 1 by 60. Okay, so take LCM 60 into 3, minus 3 minus 1 is 1 by u, minus 4 by 60 is 1 by u, 2 30, so u is equal to minus 15 centimeter. So that's the answer. So let's go to 19th question. The linear magnification of the lens M is equal to, linear magnification is Hi by Ho is equal to 2, and the image can be caught on the screen, which means it's a real image, for which the magnification has to be negative anyway. The focal length of the lens is 20 centimeter. The object distance is, okay, the linear magnification of the lens must be, it's a magnified image. So let's talk about, the focal length is given to be plus 20, shows that it's a convex lens, and magnification is equal to, for a lens it is positive, so it's Hi by Ho is equal to V by U for magnification, but this is produced a real image, and a real image is always inverted, and the magnification has got to be negative. Let me think about this. Magnification is 2, it's magnified, you know it's a convex lens, So when can you get a magnified image? When an object is between C and F, you can get an image beyond C, but it will be magnified and inverted. So this is the case which is appropriate for this. And in that case, you know that it's got to be negative Hi by HO, because it will be Hi and HO will also be negative, ratio of Hi by HO will also be negative, V by U will also be negative, and so then therefore the magnification is positive. I'm just trying to figure out, okay, let me see the object distances. So since the linear magnification itself is 2, okay, which is also V by U is equal to 2, so V is equal to 2U, and let's 1 by F is equal to 1 by V minus 1 by U. 1 by F is 20, which is given, 1 by V is 2U minus 1 by U. So 1 by 20 is equal to 2U is the LCM, it's 1 minus 2. So 1 by 20 is equal to minus 1 by 2U. So U is equal to minus 10. Yeah, that makes 10 sense, right? Minus 10 centimeter. Is there an option? Yes, there is. But if you written anything else, we have to discuss in the class. Let's keep it pending. That's my answer. There are different options available. Minus 20, minus 10, minus 15, minus 30. I have marked it as minus 10. I hope my answer is right. And let's figure that out in the class. Okay, let's section E. If you have any doubts, if you don't disagree, you let me know. Okay, so then derive 20th question. Derive a mirror formula. Mirror for the curved mirror, which forms a virtual diminished image. Virtual diminished image in a mirror is always produced only by a convex mirror. It always Bragg mirror, and you have to arrive at a mirror formula for that, which obviously you all will know. Let's go to the next question, the second part of the question. This is a question of identifying similar triangles, two similar triangles, and equating them. If an equilateral prism for a given angle of deviation D and angle of incidence and angle of emergence I is equal to 30, E is equal to 60, what is the value of deviation? Delta is equal to I plus E minus A. Okay, do you know the angle of the prism? For an equilateral prism, angle will be 60. So it's 30 plus 60, 90 minus 60, or you can cancel, so deviation will be 30 degree. And value of, done with that sum. Let's go to third question. How will the power of the concave lens change when the thickness of the lens is increased? Concave lens. When the thickness of the lens is increased, how will the power of the concave lens? Power. When they say thickness, can we say that it's going to be generally we can say that thickness means you can position it without altering the shape of the curvature. If you're going to make it thick, there is no effect. There is absolutely no effect if not going to alter the shape. But in case you're going to make it more curved, say for a concave lens, if you want to make it thicker, okay, you're going to make it more curved, the focal length will become lesser. Okay, if you're going to change the shape, otherwise you have to write this. If you're not going to change the shape of the curvature, then obviously there's no change. You can just make it like this and still make it wider, right? I don't know. In the case of convex lens, this is about convex lens, and this is about a concave lens. In a concave lens, we can make it more curved to achieve the thickness more. In that case, the focal length is decreasing. In the case of convex lens, to make the thickness more, the focal length will increase. That's what it says, okay, that's what it says. I'm not very confident about this, and that's what is the answer. I'm just trying to think, if I have to increase the focal length, if I have to increase this, why can't I make it like this? Why can't I make it like this? So if I have to make it thick, I have to increase the curvature. Increasing the curvature, therefore the focal length increases. Okay, are you clear? I hope you're clear. So this is the answer for this question. So let's go to next. What is the derivative formula? How will the power? So when the focal length increases, the power is the reciprocal of focal length, so power decreases and so on. How will the power of the concave lens? Okay, so that answers your question. Next is the thickness of the lens increases. Okay, lens is cut into two equal halves normal to the principal axis. What is that? It just intensity decreases. When the lens is cut, the intensity of the image decreases. That's all. Nothing else happens. No other change. Oh, that's all, is it? I've done all the questions. So please go through this and get back to me.